Every 4 years, we get to experience a cultural and calendar phenomenon, all caused by the Earth's orbit around the sun.
That's right, Dean. And although this event seems to happen every 4 years, sometimes we skip a year.
Okay, we've got our skies set up for any night at the end of February, and you'll notice that the constellations that you saw last year at this time are in exactly the same place.
Yep, and did you know that if you went outside at midnight on your birthday every year, you'd see exactly the same star patterns? The planets and moon would all be in different positions each year, but the stars will appear in the same place. To ensure this, every 4 years we have to add one whole day to our calendar. This is because the time it takes for the Earth to travel around the sun doesn't exactly match our calendar year. As you know, it takes approximately 24 hours for the Earth to rotate once on its axis. That's 1 day.
But a year is how long it takes for a planet to travel all the way around the sun and return to the same spot. It takes the Earth approximately 365 days and 6 hours to travel around the sun once. Over time, this extra 6 hours added up and started causing big problems for our calendar. After a few centuries, spring wouldn't start in March anymore. So what do? Add extra time to the calendar.
And since we're off by 6 hours a year, every 4 years we'd be almost an entire day ahead of where we should be according to our calendar. Since 6 hours each year for 4 years adds up to 24 hours, it was decided that the simplest way to fix things was to add an extra day to the calendar every 4 years.
Years when we do this are called leap years, and the day which we add to our calendar count is called a leap day. Now, where should we put it? Well, February has the least number of days, so let's add it to February, and we'll create February 29th. We traditionally experience a leap year in years that are evenly divisible by 4, like 2008, 2012, and 2016.
But wait, there's more. When a century ends, we skip a leap year. The exception is if the century ends on a year that is exactly divisible by 4. So, in 1800 and 1900 weren't leap years, but 1600 and 2000 were leap years. Going forward in time, you'll notice that 2100, 2200, and 2300 won't have a leap day, but 2400 will.
The reason the end of the century rule was introduced is because saying the length of our orbit is 365 days and 6 hours is still a little inaccurate. The correction is too big. The 6 hours was actually rounded up from 5 hours, 49 minutes, and 16 seconds. But hey, who's counting?